Okay, I will not lecture that long at all today. I'm just going to introduce 4.8 on Newton's method. Okay, so I was practically done with everything up until 4.7, so time-wise we're good. Okay, maybe I'll start off with this side. So I've given you enough of everything up to 4.7. All we have left is 4.8. I'm going to do a quick introduction and go straight to the quiz. And we have Monday and Tuesday to do the problems from 4.8. But I want you to at least get a feel of what's happening. So that's Monday and Tuesday. Wednesday's a holiday for Veterans Day. Thursday is our Q&A session. You can ask me any questions that you want. And then next Friday's the test. Okay. So that's what's happening. Okay, so 4.8 is on something called Newton's method. So just giving you an introduction. And where am I? I'm on page 345. Okay, there are some equations which are just not easy or almost impossible to solve for x. Here's such an example. Okay, 48x times 1 plus x to the 60th power minus 1 plus x to the 60th power plus 1 equals 0. There's no easy way to solve this equation unless you want to multiply that all out, but nobody feels like doing that. Okay, so all we can do is do a numerical approximation. Okay, and that's the best we can do, just a numerical approximation. Okay, so how do we do a numerical approximation? Okay, there are certain ways. Okay, the way that we're going to learn is something called Newton's method. Sometimes it's called Newton-Raphson, but normally we just say Newton. That's the same Newton as Sir Isaac Newton, one of the co-founders of calculus, actually. Okay, so let me show you what Newton's method is all about. So this is theory. You don't really have to take notes. It's on page 346. Okay, suppose this is the graph. Okay, you don't know any easy way to find zeros of a function for whatever reason. Okay, it's too difficult or impossible. So what's going to happen is we're just going to guess. Okay, try to make an educated guess. Now, if you're going to guess, mathematically, you're probably wrong, right? But here's the concept at least. Okay, here's the graph. Okay, see where it says R right here on page 346? That's the actual root. Okay, so I make a guess. I call it x1. Plug it in, it's probably wrong. In other words, it's not 0. But follow this logic now. Okay, suppose x1 comes out to be here, f of x1. Okay, and it's not 0. You're trying to find out when the function is 0. Let's say this comes out to be 4 or whatever. See what they're doing? They're drawing the tangent to the curve. Okay, they draw the tangent to the curve, and then this will be my second guess wherever it touches the x-axis. Okay. Plug that in, it's probably not going to work. Draw the tangent to the curve for that one, and you see I'm getting closer and closer to the real root, right? In fact, here, after just 3 tries, I guess that one, draw the tangent line. You're pretty close already after just the 4th try. Okay. So what's happening is we make our guess. It's probably not right. Go along the tangent line. That's our second guess. Go along the tangent line, third guess, and so on. And then you will eventually converge to the actual root, R. Okay. Now, if you were to do all that math, okay, we can do that. I don't feel like doing it. You don't feel like doing it either, probably. But you can do it. You find the derivative, come down until you touch the x-axis, and so on. This is the result. Okay, so ultimately, this is what you want to put in your next cheat sheet, on your formula sheet for the next test. Okay, x of n plus 1 equals x of n minus f of xn divided by f prime of xn. Okay, sometimes you can think of this as the old value, and this is the new value. Okay, so x of n plus 1 equals x of n minus f of xn divided by f prime of xn. Okay, some things you'll notice right away. This isn't going to work if the derivative comes out to be 0. You'll be dividing by 0. Obviously, it isn't going to work because you'll be dividing by 0. So ultimately, you don't want that to happen. For all the homework problems that we have, which are not that many, you won't have to worry about that. And the homework is 6, 7, 8, 11 to 16 off. And this one really isn't that long. Okay, it truthfully isn't that long. Okay, so you make your first guess, or they will give you a guess, or you might have to guess your own. Okay, x1. Okay, this is recursive, meaning you just keep repeating the process. Okay, to find x2, it's based on x1. Then to find x3, it's based on x2, and so on. Okay, so if you went ahead and did the math here, okay, and say what's the next value, draw the tangent to the curve and keep going, this is what you end up with. X of n plus 1 equals x of n minus f of xn over f prime of xn. Okay, and other thing I want you to notice, okay, how do you know when to stop? When do you stop? Okay, well, we stop when we find the function value equaling 0, right? So suppose this comes out to be 0. 0 divided by anything besides 0 is 0. So I'll be subtracting 0 on the right-hand side. If I subtract 0, it's basically like this. So x of n equals x of n plus 1. Okay, so that means you know you got the solution if you do it again and you get the same thing back, right? So let's say after the 6th try, normally you're not going to have to go out that many for me, but let's say the 6th try and the 7th try were equal, right? Then that forces this thing to be 0, right? And when is a fraction 0? When the top is 0, so you found it. Okay, so if you get two successive values that are the same, then you know you got the solution. Okay, so that's what's going on. Okay, so we're using this to estimate values. Let me show you what we're up against. So for 6, 7, 8, and so on, you'll be using this thing here. Okay, 2x cubed minus 3x squared plus 2 equals 0. Use Newton's method. Okay, so you probably had some techniques in pre-calc to solve that, but they may not all work, or maybe they're all irrational solutions. Okay, so all you can do is this Newton's method. So they give you your first guess, x1 is -1. Okay. So what you're going to do is plug in to here. So they give you a function, you need to find a derivative. Okay. Then you plug into here, grind that out. That'll be your x2. And you just keep doing it. Just do it over and over and over again until you're done. Okay. Same thing for any of these. I mean, if I show you, how far do we have to go up to? 16? Let's say 16. The positive root of 3 sine x equals x. Okay, it's known that you cannot solve this algebraically or using trig or whatever. There's no easy way to do that. Okay, so the only way you can do it is with Newton's approximation. Right? So that's what I'll be showing you pretty much next week on Monday, but you'll be plugging into this. So go ahead and put this on your next cheat sheet for the test. Okay? And the other thing I want to say is when I first lecture on this on Monday, when we come back, I'll be doing it assuming you don't have this answer button. Okay, so I'll lecture assuming you don't have that so everybody can do it. Okay, then once you get the hang of it, for those of you that have the answer button, you have an advantage. It becomes much faster to do the problems as it turns out. Okay. And that's all I was going to show you, folks. The rest of the time I was going to give you the quiz. Okay, so let me check quickly the chat to see if anybody has any questions about anything. And there's nothing. Anybody have a question about anything? If not, then you have 40 minutes to work on the quiz. And then Prasanna and I might come around and see how you're doing. Okay, so let me go ahead and give you the quiz. And then I'll set up the breakout room. So get your cell phone cameras out. And get that ready for you here. So it's one curve sketch, but you got to do the whole works, okay? Show me everything on it, okay? And Prasanna and I will come around and see how you're doing with that. Okay, so take a picture of this. The function is y equals x e to the negative x. Y equals x e to the negative x, and discuss everything that was from section 5, domain, intercepts, symmetry, asymptotes, intervals of increase and decrease, max and min, intervals of concavity, inflection points, and then use that information to sketch the graph. Okay, so take a picture, or if you don't have a camera, it's still being recorded. So you're being recorded right now. You really just have to write this down, x e to the negative x. Then all of this is the same as on section 5. So you would get it from there. And worst comes to worst, this is being recorded. You can get it off the video also. Okay, so x e to the negative x. All right, so I will assume that everybody has it now. So go ahead and get started. I'll set up your breakout rooms, and you can work with your breakout room until 1 o'clock or whenever you think you've had enough. And as usual, it's due on Monday, 12:10, and then have a good weekend. Okay, so let me stop this. Double check the chat. Okay, so. Okay, you should have an invitation to join your breakout room, please. So everybody join your breakout room.